In this video, we're going to establish the idea called the difference quotient. The difference quotient comes from if you want to look at a graph and you want to take slope of the line between 2 points, and the slope of that line tends to be, well, those 2 points tend to be very close together. If you establish a point, we'll call it x on our domain, we can establish another point called x plus h, and maybe we were looking at some sort of function that looks like this. Doesn't really even matter what it is. If we have this coordinate point here, its corresponding output, as we all know, is going to be f of x. Then over here, I'm going to establish, we're using my input, the corresponding output, and that's going to be f of x plus h. And this h represents the distance that is between these 2 points on our domain. So this one's x, and this is going to be x plus h. If we want to find the slope between these 2 points, we know that our slope formula is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Y sub 2 represents the y value of this coordinate point, which is f of x plus h, minus y sub 1, which represents the y value of this coordinate here. Let's call that f of x. Then I have my x sub 2, which is here. That's going to be x plus h, minus x sub 1, which is going to be my x value here, like this. Sorry, just x. Perform a little subtraction on the bottom, and I'm going to get f of x plus h minus f of x divided by h. This is called the difference quotient, and it's really important in the development of differential calculus. Now, how we use this is pretty straightforward. We can pick any function that we want. Let's say we're going to take 2x plus 2. What you can do is notice that you're going to have to establish what f of x plus h is. So let's go ahead and figure that out. So I'm going to directly substitute anywhere I see an x with x plus h. So now I have the 2 parts of the numerator of my difference quotient. I'm going to go ahead and fill those in. So it's going to be 2x plus h plus 2 minus, and I'm going to use parentheses here to help me out with the subtraction, 2x plus 2. So this is the first part here. This is x plus h. And this is the second part here. This is f of x. Going to divide this by h. And now it's all about the algebra. Multiply all of this out. That's going to be 2x plus 2 times h is 2h plus 2 minus times 2x is going to be minus 2x minus times 2 is going to be minus 2. And that's all going to be divided by h. Now we can see that we can cancel some things out. And this always happens when you do the difference quotient. 2x is going to cancel with 2x. 2 is going to cancel with negative 2. And so what I have left here is just plainly 2h over h. h's are going to cancel out, and I'm going to end up with 2. So this is a very simple example of the difference quotient. But let's say I wanted to do something a little bit more advanced. Let's say I had f of x is equal to x squared plus 1. Same technique still applies. We're still going to use f of x plus h and figure that one out first. And that's going to be x plus h squared plus 1. Remember, the only thing that I'm replacing is what is in the argument of my function. So instead of x and x, I'm going to have x plus h and x plus h. Now, putting them into my difference quotient, which is, I'll rewrite here, I'm going to find out what f of x plus h is. Well, that's this. So I'm going to write it right here. Minus, and then I'm going to do parentheses, and then f of x, which is going to be x squared plus 1. I'm going to put parentheses around my f of x plus h, and then I'm going to divide it all by h. Now, it's all about the algebra. Again, I'm going to multiply all this out. That's going to be x squared plus 2xh plus h squared plus 1 for this right here. And then I'm going to minus x squared and then minus 1. And that's still all being divided by h. Cancel out what I can. X squareds go away. 1's go away. And what I have left is 2xh plus h squared over h. At this point, you should be able to factor an h out of your numerator, out of both of your terms, so that you can in turn cancel it in your denominator. If you're not factoring an h out, you're not doing it right. And go back and check your algebra and make sure you haven't screwed something up. Factoring an h out of here and here gives me h times quantity, 2x plus h. Divide that by h here. And then I can cancel my h's, and I can finish out my problem with 2x plus h. A more difficult example would happen if you have a rational function. So let's start off with f of x is equal to 1 over x. This is the simplest type of rational function you can do. I'm going to use my difference quotient again. Do a little side work here for f of x plus h. That's going to be equal to 1 over x plus h. So now I got to fill in the parts of my difference quotient. 1 over x plus h is this part right here, minus f of x, which is 1 over x, all being divided by h. So now we get some tricky fraction work. We have to find our common denominator. And our common denominator is the product of our two denominators that we have. So our common denominator is going to be x plus h times x. Now, to make this actually all work, I'll show you the algebra that has to happen here. This one here is lacking the x in the bottom and the top. So we need to make sure we do x times x over 1 over x plus h. That's this part here by adding and multiplying it by x over x, which has a value of 1 that doesn't change anything. This one here, we're going to do 1 over x, multiply that by the quantity x plus h over x plus h. Again, this has a value of 1, doesn't change anything, and then we're still dividing the entire thing by h. So this is just some the basic way of showing how to do a common denominator. Multiply all of this out. X times 1 is x, minus 1 times x is going to be minus x, minus 1 times h is going to be minus h. Since I have the same denominator here and here, I'm going to write it as one denominator right here, and then that's still being divided by h. Great. Take a deep breath. Now, cancel my x's on top. And now we got this mess to deal with. What I like to do is understand that this is a fraction being divided by h. So really what I have here is h over x times x plus h. That's all of this here, is right here, being divided by h. We can make it h over 1, and then we reciprocate and multiply the second fraction like this. So we change our division into multiplication. Here we can cancel our h's, which we always want to do when we do the difference quotient. And then we end up with 1 over x squared, okay, x times x, plus x times h. The last type involves a radical. And let's say we have the square root of x. We'll do f of x plus h is equal to the square root of x plus h. So now my difference quotient is going to be the square root of x plus h minus the square root of x all over h. So here we're going to employ the use of the radical conjugate. The radical conjugate just means that if you have two radicals, maybe a and then root b, or you have a minus root b, or you have root a minus b. Doesn't matter which one they are. The conjugate is the same two values, but with the opposite sign. So if they are negative, they're going to be plus over here. And it's the same two values, root a, root b, a, root b, root a, and b. If they are positive here, then they are going to be negative over here. So it is the opposite sign. So again, same two values, opposite sign. That is the conjugate. I'm going to use the conjugate here. Root x plus h plus root x over root x plus h plus root x. So again, this fraction here is a value of 1. I'm going to multiply these together. So let me rewrite this for a little bit more clarity. So all I did was rewrite all of this, put parentheses around this. So now this part here becomes this part here, and this part becomes this part. Because I'm multiplying them together, I can make them one big fraction. So now I just have to multiply through by foiling. So I have my first, outer, inner, and my last. So my first is going to be root x plus h times root x plus h. That is going to be x plus h. My outers are going to be root x plus h times positive root x. So that's going to be plus root x times root x plus h. My inners are going to be negative, from this negative sign here, root x times root x plus h. And then my lasts are going to be negative root x times root x. That's going to be plus x. Now I will tell you that with the radical conjugate, the inners and the outers will always cancel. That's with the radical conjugate. So we have positive this, negative this, so these immediately go away. So after you do these a few times, you may only have to do the F and the L. But I encourage you to do all of the algebra until you're comfortable with using the radical conjugate. And then we have our denominator. Great. Watch what happens now. X, get X. Sorry, this is negative here, my mistake. So we end up with these two cancel. X minus x goes away. Positive h. So I have h over h times root x plus h plus root x. As always with a difference quotient, the x's cancel, and that's equal to 1 over square root of x plus h plus root x. And then we're done.